Hello, how's it going? I'm James, you're you. Let's get started. So this is going to be kind of a fun, I think it's going to be a fun one. A while ago, let's see, does this show up? I designed these little USB adapters. Oh, here's a better one. So they're USB ports to go into banana plugs so that you can connect USB devices to a power supply. And what I did on this, one of the things I did is I made this a two-piece PCB that you have to solder back to itself. And the number one feedback everybody said was, well, why didn't you just use a vertical USB? And the reality was I already had a whole bunch of these. These are the same USB ports I was using for the Mega 2 project. But then my other thought had been, I want it to go to other, oh, that one's not going to show up. Why am I doing this? I have a thing. But then I want it to be able to go to other parts, like a barrel jack, or a screw terminal, or a PHT header, or USB-C, or a whole bunch of others. So anyway, that's where this thing comes from. So what we're going to do tonight, we're going to solder up a couple of these. We're going to start with the battery one because I need it for a video that I'm working on, and then we'll go from there. I will also, if somebody wants the KiCad files, I'll go ahead and put these into the chats. If you were here last week, I tried out multi-streaming to YouTube and Twitch at the same time. So I'm trying it again this week. So let me know if you see any issues with the stream. But other than that, let's get started. How's everybody doing? I'll post a link later. There is a new Workbench Wednesdays video that just came out yesterday. Also that came out yesterday is a 25-minute talk I did at Teardown, which was a hardware conference hosted by Crowd Supply in June. I talked about picking the right capacitors for different applications. And I basically just talked about things to know when you're selecting between MLCCs, or when you're selecting an MLCC, an aluminum electrolytic, or a supercapacitor. It was just a kind of an overview talk kind of thing. So, okay, I'm trying to remember the way I did these before. I think what we're going to do is we're going to, I think I want to put this onto this, break off this part, solder it onto here, and then do the rest of the parts because this gets kind of in the way. So, now when I designed these boards, I did it with these mouse bites, and the idea is there are two rows. I want to break it off on the top. No, I want to break it off on the top one because, how did I come up with this? Actually, there was a reason why I did the two rows and I don't remember. Anyway, the center one, I did this so that you could spread them out. The one thing I haven't thought about is or haven't tried these in, if you have positive, earth, ground, negative, you might not be able to use these adapters. In which case, I'll just have to come up with a new set. My hope was, well, I made these so that you could break them apart so that you had a little bit more space that you could kind of spread them out, because like one of my supplies doesn't have the standard 19 millimeter. God, why did I? Oh, no. I'm pretty sure I want to break this off right here. Well, you know what? I have a bunch of these because I had to order them in a set of 10. All right, so that's broken off. And then what I was thinking is I wanted to be able to do this, but that doesn't make sense. And then this will go onto here, and we'll solder that up. All right, so let's get that done. I really like these adapters. So I use the USB one, this one, all the time. I did add a spot for a diode. Oh, I know what I want to make sure we line up. Plus and minus, yeah. I did add a spot for a diode with the intent or the hope of being able to maybe do reverse polarity protection, but I haven't tested that at all. So, all right, let's get this going. I'm going to go on this side because I can see it. It's a little bit easier. Oh, you know what? I already know I need to go get my other iron. I don't think this, yeah, I'm not going to bother. This one is just not hot. It just doesn't get powerful or hot enough for this part. Here it is. Do I have a free stand? No. Whoops. Okay, so I'll shut this off for now so I can put this back here, and then we're going to give this one a shot. All right, number 3, fire that up. This is like a 100-watt iron, so it will definitely have enough energy to take care of this once it heats up. All right, and as usual, I keep a blob of solder on my solder tips so that they don't oxidize while in storage. Oh, look how good. See? Look how pretty that is. It's so good. All right, let's go for... actually, I probably don't need solder. What I probably will need are these pliers, though, because I can tell this thing is already getting warm. Yeah, let's do left-handed. Yeah, there we go. Come on. I don't like how much that's being able to move. More solder. So what's interesting is I had these done from, so all the other boards that I showed, they're all from Oshpark's After Dark, but I needed this board much faster than what After Dark can provide. So I went with another vendor. What's interesting is I don't think the PCBs are the same thickness. Oh, darn it. I moved it right at the last second. Because with the Oshparks, this feels like it sat in the holes a lot better. All right, so that one's stuck on. Now we'll do item number next. Yeah, that's on there. So now I should be able to come back and do this side. This one is not getting onto the board. There it goes. Nope. Come on. Wick all the way onto the board. All right. Not super happy with that. Let's give it a second. Yeah, it's much better. All right. And then let's come over here. I'm pretty sure they did these with leaded solder. I think it's just that these huge, I mean, basically, I've got two big copper plates that are getting combined together, so I'm not too surprised by the difficulty in soldering them. All right, that looks good. Ah! That's a dropped microphone. That's not going to do me any good. Rip it out of my shirt. Nah. All right, is this too hot to touch? Yes. Okay, so I'll give that a second to cool. There it is. This is gonna be the JST, so we'll plug that onto there. That will work just fine. Still pretty hot, but I'm gonna try. All right, and then, interesting. Yeah, see this didn't, I'm a little bit disappointed. This didn't come through all the way. So on my other boards, there's like, this sticks out more. I wonder if I needed to shave down the mouse bites a little more. Because that's not, or I guess I can touch this. It's not gonna. Look at this one. No, okay, I guess it's about the same. All right, whatever. Not how I remembered it. Okay, so let's do, all we really want to try to do is get a little bit of detachment on both of these sides. Do I see a little wicking action? I think I do. Let's do the other side. So the very first version I did this, I only had the left side. I didn't even have a way to do the, you only soldered on one side, which is what this one did. And I immediately realized as soon as you put any kind of force onto the board, it just bends. And so I redesigned it to have more of like a slot that the plug side PCB goes into. There we go. All right, and then actually while we're back here, we're going to go ahead and put the LED and resistor on. Now, one of the changes I made from the very early version is I put an LED pad on the front and the back because on some of my supplies, it wasn't visible. So I was like, that's not gonna work. All right, so I'll get my smaller iron going, and then we're gonna put a green LED right there. That should work well. Hello, Bellum. Good to see you. Welcome to the stream. As always, it's good to see you. Okay, so now let's go to here. So this is definitely going to be the anode. Let's keep with green LEDs. Pretty sure this is a 1206. Actually, now I'm looking at this, I wonder if this is an 805. Nope, that's a 1206. Oh, shoot. Huh. I didn't realize. Maybe did I? Huh, yeah, so I used the 1206 footprint for both the resistor and the LED. Which actually, okay, that makes sense because I probably did 1206 knowing that some people would be, or more people would be comfortable with soldering the 1206. But on my other boards, I put 805 resistors. So I'm going to go look and see if I have a 1K or something around there in 1206, because if I do, then we can use those up. Oh, come on. This ground plane is just so big. Yeah, I don't like that. Let's get... Okay. Then we can solder this side, which should go a little bit easier. I'll do this. Okay, let me go see if we've got 1206 resistors. I'm going to go to the secret location. Man, that is, I do not like where that's at. Put that in here. Okay, let's see. SMD resistors. And in this box, I have a boatload of 805s. I see 0603s, tons of those. I see 10 microfarad capacitors. Well, that's not right. 100 ohm. Yeah, that's a little low. 0402. 0603. Really? All right. Yeah, so I do have 4.7K. Or no, these are 47K. That's not going to work. Okay. We'll keep with 805s. It'll just need some extra solder. Let's try right there. Right there. All right, and I'll just pour some of these out. It's not like I've ever lost my 1K resistors before. I don't like these tweezers. Do I have something better? I do. I do. So this week's Workbench Wednesdays is on the Picoscope software, which, if you've been around for a really long time, Picoscope was actually one of the very first live streams I ever did. In fact, it might have been my first successful live stream where I didn't have like a major technical issue. It was back when the Element 14 community had sent me a 2000A to do a road test review on it. And so part of that review, I did a live stream. Or maybe it was like after I wrote the review, I don't actually remember now. But one of the measurements I did was we used the scope, the scope input to find the fundamental frequency of the arbitrary waveform generator that was built into the Picoscope. I thought that was kind of a fun measurement to do. All right, so that looks pretty good to me. Lots of flux, but we'll worry about that later. Now I can break off this front part because I definitely don't need it anymore. And I wish I could remember why I thought I needed it in the first place, but now I forgot. All right, put that off to the side. So now we'll do the resistor in here. So which side is the LED? That side's the LED. Let's do the LED first. LED. Gotta find the cathode. It is that side. So then we'll take this and we will go 1, 2, buckle my shoe, 3, 4. Nope, I'm losing it. Okay, there we go. That's what I'm talking about. Nope, that didn't work out. Okay. There we go. Now we can do the other side. Hey, Bread Boy, welcome to the stream. ASMR soldering, yeah. You know, actually, for a long time, I wanted to do really high quality recordings of like the flux sizzling and wiping of the thing, and yeah, I always thought that would be really fun, but I never got around to doing something like that. And then now you probably wouldn't pick up any of the noises because I've got noise canceling turned on to hide my air handler. But that's just the way it goes in the summer. Don't have a choice. Years ago when I first started streaming from this location, so I'm in the basement of a house, and it has windows, but they're all solid, so you can't open them. So it's really hard to get good airflow down here. The first year I was streaming, I didn't have any kind of air conditioners, so I would just I had a big fan blowing air from the air conditioned upstairs to downstairs. And I remember this time of year while streaming, it would be in the 90s while I was on camera, and it was just like, now I'm like, oh, it's a little warm right now, and it's like 74 or about 25 degrees. So, you know, and I've got a dehumidifier now, and so it's not even humid in here. So it's actually quite comfortable. But it's funny to me because I'm like, it's a little warm. I don't know. Oh, I had to turn my other fan off, and so now the air's not as nice. But compared to how it was a couple years ago, yeah, night and day. All right, want to make sure we get a good solid connection to those ground pads or the mechanical pads so that, yep. Okay, so this is going to be a little tricky. Let's see. To get the pads, I gotta remember if I do these as gold plated that we'll need to plate them. All right. So that looks like I got that, and then, oh yeah, that looks like that went on really well. That looks really good. Okay. I think we're ready to clean this up. You have a Weller WED. Yeah, actually the WED-51 is a really nice iron. I used to teach electronics at a tech shop, and that's what we had in the labs, and I really liked them. The one I have now is a WXR3, which was given to me from Weller in the Element 14 community years ago. I only use rosin core flux, so on a brand new board with brand new parts, I don't feel the need to add flux for most soldering applications. If I'm going to do drag soldering or try to remove something, then I'll add flux. But like brand new parts with a brand new board don't usually need flux. Additional flux, I should say. Okay, so speaking of flux, let's clean up the flux residue and then attach the Panoma connectors and go from there. Hey, sweet Tingy Barbecue. VMC Propulsions, VMCD Propulsions, welcome to the stream. So for those that don't know, I am streaming on Twitch and YouTube. So Twitch, Bald Engineer, YouTube, Atoms. Twice the stream, but the same amount of fun. Yeah, the best part is my jokes don't get better. They totally don't get better. Let's see, I need a cleaning brush, which is actually at the real soldering station. There it is. So we'll clean this up. So even though the flux I'm using is no clean flux, that doesn't mean you shouldn't clean it. It just means whatever it leaves behind is supposed to be inactive or inert, but I still like to clean it anyway. Yeah, so actually, I might come back later and hit these pads with flux because this solder did not wick up. Let me use this. The solder did not wick up onto the pad like I was hoping it would. So it's fine on the top side, but not on the bottom side. Yeah, actually, yeah, I'll just do that later because this board will never see more than 1 amp, so I'm not worried about it. Okay, so here's what I want to do now is let's grab, oh yeah, we're gonna grab these. So I found these, so when I was designing these boards, I could not find board mount banana plugs. And so I ended up finding just this portion, and that's why I do the two pieces of board so that I can make it basically vertical. And yeah, it was really annoying. But you can get these like in packs of 10 for, I'll say, a good price, but it's still like $1 a pair, so it's not necessarily cheap. But I think for adapters like this, I think it's an okay price to pay. I looked for like even though I don't like to do this sometimes, but I looked for something like on Ali, but I couldn't find anything I liked that was a horizontal mount banana plug. So yeah, am I using 99% alcohol to clean? Yeah, I bought a bunch of 99% years ago. At this point, some of it may not be 99% anymore, but I just use I use medical or industrial grade IPA, and the only reason that I like the industrial or the medical grade or industrial grade is because if it's sold as rubbing compound, it has agents in it to make it taste bitter, which just to me is more contaminants. But yeah, anything above 90% is really good for cleaning electronic stuff. The 70% stuff you get at the store is great for antibiotic reasons, but it's not great for cleaning. So, but then of course, as soon as you wait 15 seconds, your 99% turns into, okay, there we go. So I tell you what, I'm gonna go grab a cable because I want to do a ohm check, and then we will, oh, I don't know how I'm gonna plug that into anything. Well, maybe we'll just build the other adapters, and I'll play with that later. This is what I'm looking for. So I want to bring this back with me. Hey, sweet tangy. Let me catch up. Hey, prototype zebra. Yeah, actually, so I taught at the one in Austin, and the guy that I was that was helping set up the electronics lab, he and I reworked all of the electronics classes. We didn't like any of them, and so yeah, that was a huge frustration between the two of us. Okay, so the first thing I wanted to double check is, so almost all of my LiPos come from Adafruit, which their batteries have this pinout. I don't know how else to describe it. So it's always, yeah, it's always positive, negative in this direction. So first thing I'm noticing is I have a positive marker here, and then this is the positive. So it looks like I got the connector correct, which is not always the case. And then we're going to do an ohm check. Sci Guy Geek, welcome to the stream. Yeah, actually, I got my 99%. I had a bottle of 99%. I think I got it from CVS. But I think most stores, most pharmacies will sell 91%. It's just, you have to remember, if you're buying it at the store, it probably has the bitter agents in it, and so bittering agents. And so I just like I said, I like industrial or medical grade because it's not rubbing alcohol. Okay, so that's looking really good. And then just to point out what the plan is, let's see, I don't have a good. The problem is the power supply I would have plugged this into doesn't work anymore. Maybe, oh, here's what I'm looking for. So the idea is I've got my battery, I can plug this in, and then, well, I guess the battery's charged. I didn't think about that. Well, okay, well, I guess we could test the LEDs. There we go. Did not think about that. Yeah. Huh. I almost feel like I should have put a diode on there. Oh, but then I wouldn't be able to use it with an SMU. Okay. All right, well, that's how that's going to work. I'll probably build up another one of those. We might even do it tonight, and I won't put the LEDs on it. Okay, so now I've got one for USB. Got one, oh, that one needs to be tightened. That is really loose. Need to get a wrench. Hey, LT, good to see you. Silent, good to see you again. Hey, Alex. Yeah, I mean, the thing is, the only reason I bought 99% was because I could. It was like the price difference was minimal. I think what you have to remember though is alcohol or IPA, isopropyl alcohol, evaporates really quickly. So my 99% is probably not 99% most of the time I'm actively using it. It's also the same reason why medical people say use 70% to clean wounds because anything above 70% evaporates too fast. So it's not as effective at cleaning or killing like bacteria. That's why they prefer you use the lower percentage, because I guess it stays active for longer. Although in my opinion, it seems like when the 91% just evaporate down to 70%, but then I guess maybe you have more water versus alcohol. So whatever. Anyway, doesn't matter. That's more stuff than I know about. Okay, well this one's gonna be easy, so we're gonna do this one next. This is for the screw terminal. And so let me make sure this actually fits on here like I expect it. So will it go on like, no, it should go on like this, right? Oh yeah, I did that right too. Man, I am so happy about that. Okay. All right, let's do that one next. We'll call that item number next. So this time I am going to break it off at the big part, or this other one, because I'm trying to remember why I did it this way. I feel like I had a reason. Yeah, see, that doesn't make sense because you can't, yeah. I don't think that's going to work. I don't think that's going to do anything useful. Bought a solar camera from Kitty Hawk. I don't know what that is. Stop streaming if the battery hits 80%. Put a 10K milliwatt hour battery. Pass through. Okay. Radars or microwave circuits. I have experience testing radar, but not designing anything that uses radar, and I have limited RF experience. I would argue it's going to depend on what you want to call RF. I guess you're saying microwave, so, but that's still 2 gigahertz or something, or 20 gigahertz. What am I looking for? I'm looking for these. I want to see if I can clean these mouse bites off a little more, which I would feel a lot better if I had my safety glasses on. Yeah, I'm going to leave them because I don't have my safety glasses on, and that's just going to make a whole bunch of small pieces of fiberglass go flying everywhere. Okay. Plus, minus, plus, minus. All right, let's get our thingy out. Let me switch irons. By the time I'm ready, that one will be heated up. All right, come back to here. I should have had this the whole, oh, that was the tool I was looking for. Bring this back to here. All right, we're going to do this, tighten it down, and then get the camera ready. Come on. There we go. Yeah, actually a file, Johnny, would be a really good thing to have down here. So I'm going to skip that for now. But yeah, that's actually what I need, because then I could just get in there and file that away. Whoops. An FMCW. Yeah, I mean, the only time I did anything with that kind of stuff was, it was a couple of years ago when I was at Roder and Schwartz. We had some stuff on our high-end oscilloscope that could decode the chirp from was it FMCWM or FCWM or FMCW? Basically automotive radar. But I didn't really get too much into any of the design stuff because that was just that's pretty far outside of what I normally do. It's a cool technology though, that was for sure. Nope, I don't like that. That's okay. I think this one's gonna solder. See, these just fit different than the other board, which is so weird. They're both supposed to be the same thickness. Okay, get in there. Nope. Why isn't that doing anything? There it goes. All right. Then we'll get the other side. So this time I think I am going to flux on the back side just because there's so little copper that I need as much help as I can to get the, well, basically I just need as much help as I can get. Okay. Try and flip this guy. Bring the, ow, 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 ow. Wouldn't you know, a board that's almost entirely copper stays hot for longer than you would expect. Yeah, it's hot. I mean, this is Osh Park After Dark, and so I can't hold it. And so the gold color is exposed gold, and then the orange color is copper with their clear solder mask on it. So you can see the boards are basically pure copper. Yeah, which is why, especially for this part, for the combining the two boards, I need the 100-watt soldering iron just because it needs to deliver that much more heat. But it looks so cool, so of course I had to do that. All right. Okay. Ah, my tip's getting dirty. All right. What I meant to do is this. Go ahead and put some on this side just so it's protected. And then I'm going to try what I was hoping I can see happen. Yeah, that's working a little better this time. So I've got the tip on the other board. Yeah, I like that much better. So I pressed into the other board, and then I fed the solder into, as best I could, to the board that's coming through the bottom so that it would wick up onto it. This one's going to be a lost cause because it's not, I guess I didn't get this on here straight at all. Yeah. Oh well. It really looked straight when I was looking at it from the angle. How hard would it be with a 60-watt iron? I think it would work. I think that's what this iron is. Yeah, this one's a 65-watt. But I have my relatively small tip on it, and so I think it's the tip on that case is what's really limiting me. The other thing is I could have turned the heat up, and I could have used flux, which even though it's new board, it shouldn't there's not much to oxidize. Flux will still help move the heat around a little bit. I mean, you can make it work with a 60-watt. It's just the biggest problem is my tip wasn't big enough. So yeah, I can see it's not straight now. Oh well. All right, so let's see. This is the screw terminal. Yeah, let's go ahead and do the same thing we did last time. Let's put the LED on. Might as well. So we'll 10. Oh, you're not hot yet, are you? There it goes. Okay. So that goes there. And then let's see, the cathode is, where'd my tweezers go? Where did my tweezers go? Cathode is there. So we'll bring this in. I don't like this setup. I'm just going to let that get stuck where it's at. There we go. Now my hand's in a little bit better spot. All right. There we go. So we'll do the same thing for Mr. Resistor. So these are 0805 or 1206 pads, but I don't have a 1206 resistor that's suitable. So I'm just using 805s. which for this case is going to work just fine. It's fine. Everything's fine. Yeah, that's terrible, but we're going to have to go with it because I don't have my... Yeah, that's a little better. All right. I'll have to do some cleanup before I take pictures of anything. I would not recommend hot air surface mounting LEDs. I've done it. It almost always causes the lens to get discolored because it basically cooks it. However, you can hot air it from the back of the board and it will do it'll be fine. But yeah, you definitely have to be careful when you're using hot air. I can't tell. I wasn't paying attention if that was the resistor pad or the LED pad. So let me go and open up the files and I'll show you what I'm looking at in just a second. Open project banana to, let's see, what one are we doing? Screw terminal? All right. So I do know some of the hardest to use hot air with are neopixels. You do not want to put hot air right on top of a neopixel or the WS, what are they? WS 218. I don't remember what the... All right. So yeah, so this is resistor and then the LED. Okay. So that's what the design looks like. It's not too complicated. It's basically just a front and back board. The back is, Anyway, I just wanted to make sure this is the part we're doing right now, and that's the resistor, and then the LEDs on the other side. Okay. Yeah, 2812. That's what I was trying to think of. What's the max voltage that the board will be subjected to? Whatever you subject it to. Yeah, that's the thing you got to be careful about. You could easily blow up the LEDs. However, they're entirely optional. So I'm putting them on because to basically pop the resistor back off would take just 1 second, right? It wouldn't be that hard to disable the LED. So that's why I'm not too worried about having them on. The thing that I'm more concerned about is reverse voltage. If you reverse the voltage, most LEDs can only handle like 5 volts reverse. And so you want to be careful about that, is how much are you applying there. So, but overall, I'm not too worried about it. I mean, now here they are. I do have pads for diodes, and I do want to do some testing to see how well a Zener or a signal diode would do in terms of reverse protection. My hope is that they would at worst blow themselves up, but at least cause a supply short circuit protection to kick in, which I just now realized probably isn't really enough because most people don't have overcurrent protection enabled. Do they? Yeah, didn't think about that. This is supposed to be the resistor. Alright, so I'm just going to try and flux it all up. Nah, that's not going to work. Too big. Too big, too much metal. I need... That's what I get for talking. Bicolor LED. Yeah, that's actually the problem is, and I didn't realize this when I designed my my power controller for the Raspberry Pi. I have a red LED in the design in parallel with the reverse protection circuit. And so the idea is if you reverse the barrel jack of the power supply, then the red LED turns on. The problem with that setup is red LEDs especially only have like a 5-volt reverse breakdown limit. And so in normal operation, it's being reversed with more voltage than it's spec'd for. So, whoops. I don't know how I'm going to get this off now. Maybe the bigger iron can do it. Over on the Twitch side, welcome to all the people that followed. I just now realized I don't have notifications turned on, so I wasn't hearing didn't hear any notes. Notes. What do you call it? Sound effects. Notes. Come on, that was dumb. All right, let's. All right. Shoot. I don't think I'm gonna be able to do this without hot air. Put a 200 in series with the LED, the polarities backwards. Well, no, that actually the resistor value wouldn't matter in reverse, because, well, what I'm saying is, so yeah, so if you put a small value resistor so that it basically acts as a current limiter when the diode is reverse biased, then yeah, you're right, that would help. What I'm talking about, or what I was really talking about, is the problem with using an LED as a reverse indicator is that their reverse breakdown voltage is only rated for like 5 volts. And so it's not that it'll start conducting, that's actually, well, yeah, this LED is not going to conduct in reverse, that's for sure. Come on. I don't think I can get this off of here without, I'm going to need, okay. Let's come back to this one. The problem is right now I don't have a good way to set up hot air. And I'm going to have to hot air this to get this LED off. Which is now making me rethink my whole, oh, it's going to be easy to disable the LEDs. Okay. Okay. Yeah, I'm going to come back to that one because I got to think about how I want to. I don't have a good way to set up hot air over in this area, so there's not much I can do with that one. Hey, Flask. It's been a while since I saw your name show up. You're full of hot air. Oh, that's a good one. That was good. All right, so we'll break that off, and then we'll break this one off because we don't need it. So I only have one of each board out for the moment. So we're gonna move on and do a barrel jack now. And so yeah, we'll do that. Okay, so this one is going to sit like here. And then I wish I had a better way to tell if it's level. Because like right now it looks level. Well, not anymore. Maybe I'll, ooh, well, it might be level, but it's not straight, so I don't like that. It's still not where I'd like that to be. Okay. Well, I'm going to go with that. Let's see how this works out. Oh, but it's too far over. Shoot. Now it's. This wouldn't be so bad if I didn't care how nice it looked. Nope. Oh my gosh, that got hot fast. What was I thinking? How many times do I have to say it? These things are nothing but pure copper, so of course they're going to heat up. Oh my gosh. When I moved my hand, when I went to move the pliers off, well, that's as good as that's going to be. I'm tired of messing with it. Do I have enough to make a jig? I don't know. I'm not even sure what I would do. I mean, I think the thing I would do is on the next batch, I would make the slot smaller. Because I feel like maybe the slot is just a little too big right now. Like if I did 0.5 millimeter. Like I guess it would almost be better to have to kind of force it into the slot a little bit. Okay. And I'm trying to think, what would a jig even look like? Like, I guess. You know what? I don't know how to build it, But what would be nice is if I had something where I could just take this whole thing and just set it like all upside down and do the bottom first, but then have like a block with a slot in it that this just sits in. And so it basically forces everything to be in the right place. But I can't think of anything that would be able to do that other than metal. Yeah, it's a little crooked, but we'll live with it. Because these things, I mean, these things are just getting ridiculously hot. I'm really excited to see how much current I can push through them. Because it's going to be a lot. It's going to be a lot. Oh man, did I put this on the right way? Yes, okay. I mean, technically you can put this board on in either direction. It's just that it has silk screen to indicate plus and minus. Which now I think about it, I guess it really doesn't need that, does it? Okay, so LED will go first this time. Yeah, we'll call it back. Agreed, Alex. I think, I don't know. I thought the first boards were tighter than this. I wonder if I didn't actually reuse the design. If I recreate it? No, I did. I used the same design. Or maybe it's just the first boards, I wasn't doing them on camera and I paid more attention to what I was doing. And so it just seemed easier. That probably has a little to do with it. But yeah, I think if I was to do another run of these, I would make that slot just slightly thinner, just to force. It would also force a lot more metal on metal contact. I guess the other thing I could do too is I wonder if I could taper the slot a little bit, just so that maybe it like kind of keys in, and then that way there's also room for a solder to come down the sides. I don't know if that would work the way I think that it would. All right, that's looking pretty good. Can I touch this yet? 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 So these boards were done with Osh Park's After Dark service, and this board was done with somebody else. It doesn't matter. It was whoever was really cheap, and it was the cheapest place I could find. Okay, so now we need another resistor. Right? Resistor, LED. Yeah. Okay. Where did my other tweezers go? They're there. Let's use these. Let's use these. All right. Well, I was going to redo that, but that's actually fine. I'm happy with that. I'm good with it. Nope, I'm not. It's not on the pad. So the problem is, like I mentioned earlier, I made the pads 1206, and I don't have any 1206 resistors that are suitable. They're all way too big. There we go. And then over here, there we go. Now I can do the LED, and this time the cathode is going to face me. I can't tell on those. So the cathode is going to go this way. So for those that came to last week's stream, we did the Blinky board for the Cerberus 2100. However, I had to end early because I didn't have the correct part. I haven't gotten new parts yet. In fact, I think I'm going to end up doing the video and just come back and do that board later, because I've got a lot of stuff that's in the backlog at the moment. And I have a feeling that that board is not correct anyway. I think I made a serious mistake with it. Hey, Core Bob, good to see you again. Can I touch this yet? Can I touch this yet? Yeah, that's... Hey, Ant Pirate. Is it cool enough yet? No. It's always an instant no. All right, so then we're going to do... So what I'm going to do is, just so that this will stick in place, I'm just going to dab the solder real quick on the top side, just for just so that it stays there. And then let's see, that's pretty flat, and then we'll solder everything from the bottom side. Yeah. All right, let's do this. I will pick up the big one. Actually, since Silent said something about the 60 watt, I want to see what happens if I use my 60 watt. Let's see if it can do it. Because these have some pretty decent thermal relief, I think. Yep. Yeah, that's good. Man, that's so satisfying to watch. Yeah, there we go. All right. Super excite. Oh. I don't actually consider Oshpark boards to be expensive. Maybe you could say they do have a higher price, but the fiberglass material is high quality, the copper is higher quality, the silkscreen you can get to much smaller. It's ENIG, which is gold plated. The turnaround time, it can be relatively fast, and you can get stuff like After Dark. You know, that's something that you can kind of get with some of the other vendors, but as soon as you start using like clear solder mask, their prices go up. Yeah, I mean, for anything less than 100 centimeters by 100 centimeters, I almost always do it through Oshpark, because once you factor in, at least for the US, once you factor in shipping time, it's almost faster than Asia, a board house in Asia, and it's almost always the same price, because you know you're looking at a $20 shipping charge to get it in a reasonable time. So small boards actually are really economical to do through Oshpark. Plus, they're much higher quality. You know, when you're terrible at soldering like I am, having a high quality PCB can be significant. They very rarely do I have Oshpark boards delaminate while I'm soldering, because I'm terrible. What is this? Where did this come from? Oh, I thought it was an IC. It's the mouse bites that I took out. Now that said, I mean, yeah, when I get to really large boards, I usually go with somebody in Asia, just because the price then can be pretty significant. But for the most part, anything that's small, I do through Oshpark unless I need it. The only real exception is when I need it faster than Oshpark can provide, and I pay for expedited shipping or expedited processing through the Asia house, which offsets the cost anyway. So, or increases the cost, I should say. It's not really an offset. Anyway, let's clean this one up. It's got flux all over it. I can feel my fingers getting gross. Oh no, I'm almost out. Well, this bottle's almost empty. I guess that's not the same thing as almost being out. Okay, how did I lose my cleaning brush when I have two of them over here? Oh, because I placed my thing right on top of them. That's why. That was silly. I'm so silly. Plus, Osh Park screws up quite a bit. Well, that's news to me. I've done, I think, I know for certain, over 50 boards through them. It's probably closer to 70. And I've only had one. Well, I had one show up with the silk screen was wrong on the back. And then there was one they caught it before they shipped the boards out, or maybe it was after they shipped the boards out, that there was that they had messed up one of the layers, which they just reran and sent it out. As opposed to, say, the vendor I used in Germany, who I did 3 orders through, and 2 of them were done wrong. They lied their ass off on the 3rd one, and actually they lied on the 2nd one as well. So yeah, I mean, I don't know. I guess everyone has, I guess it's kind of like cars and everything else. As soon as you say a PCB vendor, somebody's going to say they're terrible and somebody else will say they're great. It just depends, I guess. It's one of the reasons why I don't really do like sponsored videos by PCB vendors. First of all, I don't think $20 in free PCBs is enough of a reason to take a sponsorship. But second, it's, I don't know, it's so subjective. So yeah, I don't know what to tell you, Alex. Like I said, now granted, you might do more PCBs than me. Out of the at least 50 that I've done through them, only 2 had an issue, and one of them they caught before I did. So I don't know what to say. Also, it's like literally like 5 people. There are 5 people that are working together to make it all happen. So I'm not going to give them too hard of a time. Okay, this is the least favorite one that I'm looking forward to. And, oh, wait. Wow. Oh, no, it's because I didn't finish that one, because that's the one we just finished. I did want to double check that I got the center pin is... I think I made it so that the center pin is positive, but first, are we shorting out from positive to negative? Because then that's really bad. No. And then negative to the barrel. And then, okay, I should just be able to do this. Let's just do this to here. Cool. Beautiful. I'm actually really excited to have this barrel jack one done because I want it to be able to just use, I've got these barrel jack cables, like extension style cables that I wanted to be able to use. And so now I can finally do that. What do you make with a custom PCB? I mean, in this case, I made an adapter so I can go from a barrel jack to banana jacks to plug into a power supply. Virtually every piece of electronics, virtually every electronic device in the world has a printed circuit board inside of it. So most of the PCBs I do are something to support some other electronics component or device. Chat might have a better answer to that question. the big misconception that people have about PCBs is they think it's the circuit. So a lot of times I will get emails from people asking, I need a PCB that does X. And it's like, no, you need a circuit that does X. The PCB, or printed circuit board, is just one component of that total design. But I get why people don't seem to associate that. You know, it'd be kind of like saying, I need a wheel that goes to the store. It's like, well, no, you need a vehicle to go to the store. The wheel is just one component of it. All right, I'm really excited about this one. And the more I think about it, the less I think I'll use it, but whatever. All right, let's move on. This one's going to be USB-C. Oh, and then what's the resistor value? Is it 5.1K? Except, wait. This is the upstream port. Wait, I might be thinking about this wrong. Since this is the upstream port, yeah, it needs, I need a 10K pull-up. But is that what I designed? I just realized. I bet I did this as a downstream port. Don't put that in your mouth. What are you, stupid? Darn it. Hey, spark arrestor. Yeah, so my USB-C adapter is not going to work. And this is not the kind of board that I can bodge. I didn't think about this. This is the upstream port, so it should have been, or I hate this wording because I always, it's backward to me. So this is the downward facing port, and your device has an upward facing port because it's from the host to the device. And so a device uses 5.1K resistors as their pull down. The downward facing port, or the host, is supposed to provide a pull-up resistor for what value it can provide. And I forgot to do that. Or I have them pulled down instead of pulled up. So, okay, you know what? I'm going to solder it anyway and just see if it'll work, because maybe most devices don't care, and go from there. But I'm definitely going to have to redesign the USB-C board, because that was I just didn't think of that until just now. Bummer. Yeah, I'm actually thinking most devices won't care because they just have dumb pull downs anyway. But it really, that's what I should have done it as a upward facing port or down facing port. Okay. So here's what I'm going to do. This is not a mistake. It's a feature. I'm just going to rename the file to USB-C UFP, and then make a new board called the DFP. That's thinking. Yeah. Yeah, the more I think about it, is most devices don't care because they just have the pull downs anyway, and it's really only the upstream side or it's only the DFP that's actually checking the voltage anyway. So no, I guess let me rephrase that. That's still not. If anyone actually cares, it's probably it doesn't matter. The point is most devices won't care, so I'll just won't put resistors on. But it would be nice to have the correct resistors or have one with resistors so that you could do like testing with it. Am I really going to try it with this one? Yeah, we're going to try it with this one. I'm going to take this to 400 and see what happens. Yeah. Yeah, I think in retrospect, this is going to work fine for plugging it into a power supply. But I do want to make a version that has the correct or has the option for the correct pull-ups, because I think that would be useful to have as a tool. I should leave this alone. Well, Silent, if you're still here, my 60-watt iron did just fine. I did have to turn the heat up to 400 degrees, but it is... God, you're in the way. Don't be in the way. If you're not going to be helpful, get out of the way. Lead, follow, or get out of the way. Okay, that was quick. Is this hot? It's not nearly as hot, too. Maybe using the 60-watt iron actually makes more sense. I don't know. Ow, 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 ow. Okay, never mind. That's a lot hotter than I thought it was. Well, USB-C's versatility doesn't have anything to do with the pull-down resistors. The pull-down, so the idea is you use the resistors so that the host can tell the downstream device the maximum amount of current that it can draw. And so most devices aren't going to care. The other thing that the pull downs, the resistors provide is it lets the host know if something is attached. But we don't really care in this case because we don't have a host. So, I mean, overall, I think we'll be fine. But I will do a different version that has it correct. So, this must be the LED. So the resistor will go up here. It's just one of those things that I should have thought about it. I just wasn't thinking when I designed the board, and it was just now that it occurred to me. It wouldn't make sense for wouldn't make sense for what I was doing. That's okay. It's not going to be that difficult to design, so. Well, I take that back. Actually, the hard part was on this one is just trying to keep the ground planes looking really nice. or the copper pores, not the ground planes. Because I was like, I want them to look really nice and cool, especially when you can see them. All right, I was bound to do it once, and I just did. I put the board upside down. This is the back side of the board. Which doesn't matter. All right, whatever. I just realized it doesn't matter, does it? All right. Yeah, ultimately it will not matter. All right. Yeah, thanks, Bell. Appreciate that. You know, LT, I remember, not that I was the only person to ever have this thought, but I remember back in probably like, I'm trying to remember where I was in life. I remember thinking there needs to be a universal power bus. And at the time, I thought it can't be USB because there's just not enough intelligence to make a multi-voltage, multi-current supply. But what if you could? And so I also wondered now if the original designers of USB realized that it actually would end up becoming more of a power bus and less of a communication, like protocol bus. Especially as more and more devices just became integrated. And I guess, yeah, I guess they could be USB internally, but I don't know. It's a good question. What is happening here? Soldering up some boards I made to convert various standard connectors to banana jacks or banana plugs for use on a bench power supply. And then in a few minutes, because I think this is the last one because I screwed up the screw terminal. I might reset my camera so that we can actually look at it on a power supply. All right, this is going to be the fun one. So let's get the port tacked down. So I went with the 6, I think it's the 6 conductor 6P variant of the USB-C connector, which should be basically just power only because it's got these CC pins, which obviously we're not going to use. Oh, I got solder on the connector. I'll clean that off in a minute. Oh, and I need to put another LED on here. Let's do that real quick. But anyway, it's only got enough pins to basically be a power connection, which makes it really easy to solder versus the full, like, I don't know, 16 pin version, which has 16 pins in the same amount of space. It's crazy. Hey, Thevanos, that's a name I haven't seen in a long time. Hope you're doing well. Yeah, actually, I didn't know about the evaluation notes, but I remember reading most of the spec when I was a kid. I was in college, and then I did some USB plug fest when I worked for Agilent, and so I got to know some of the people involved with USB then. Although I couldn't even name anybody. I can only name one. I can only think of one person. It's because he had the same name as me. Actually, I wonder. I might, now that we talked about this, maybe I will reach out to him and see what his thought is. I don't remember what he did with the spec, but I remember he was very active in a couple of the committees. So if I ever bring back a trivia, which I probably won't, but a trivia question I would actually add is, according to the USB spec, what is the maximum capacitor value you can have on V-Bus? And the answer to the question is, of course, it is a trick question. There is no capacitor value specified. And somebody's about to go, no, it's 47 microfarads, or 100. I forget what the number is in the spec. However, the spec says capacitance, not capacitor. And so they want a certain capacitance level, maximum capacitance level on a bus. And so it takes into other factors, not just the size of a capacitor. But the spec never actually says a capacitor value. You're just not allowed to present more than, I think it's 100 microfarads, maybe it's 47, I can't remember. But that's the weird thing is it's like, well, how do you even, the only way you can demonstrate that is by measuring the slew rate of the droop that's caused when your device attaches. Which also, by the way, if you get really clever, you can put tons of capacitance on V-Bus as long as you turn on the cap slowly. So yeah, I just started doing streaming, multi-streaming to Twitch and YouTube. So yeah, this is only like my second week back on Twitch. I wasn't sure if I was going to keep doing it, but at this point I'm going to for the moment because it seems like it works pretty well. So we'll see how that keeps going. Hey Timothy, good to see you. Welcome to the stream. Power over IP cables. That one doesn't surprise me nearly as much, just because I can see that being really useful in a lot of industrial applications. Soldering irons keep losing heat at the tip. Small amount reading, they're oxidizing. Yep. So if you're using conical tips, those are the ones that look like a cone. Those are terrible they're notorious because I don't like them, so I call them terrible, but that doesn't answer your question. Conical tips, the very end of the tip oxidizes fastest because the plating is the weakest, and a lot more heat is concentrated in a small area, so they tend to burn up faster. And so if it's a conical tip, all I can say is you've got to keep it tinned. So like every time you clean your iron or clean the tip off, immediately put solder back on so that it stays wet, so to speak. The other side of it is just, yeah, you just make sure you clean your tip. And then when you're done using your iron, always, like as soon as I turn mine off, I stick solder onto the tip and let it just soak up whatever it can. So that way it protects the tip from oxidizing while you're not using it. Hey, Talk, good to see you. Yeah, you need to you absolutely need to be tinning your tips a lot. You want to keep solder on them constantly. That's why even after you do 5 or 6 joints, clean your tip off, put a fresh dab of solder on it, and keep going. You want to do that because as you're going through the soldering process, you'll start to collect the residue of whatever the flux is burning off, and you just want to get that stuff out of or off of the tip. Workbench Wednesdays, soldering myths. So I will share this video. So this is a video I did many years ago. You'll be able to tell because I'm so much skinnier and have so much more hair. And it's basically how to properly keep proper tip maintenance. It was sponsored by Weller, but like most of the sponsored videos, I got to pick I got to do all the content, so it's not really a Weller commercial. Even though I mean obviously everything in it ends up being Weller. All right, so now we're going to try and get back here. So I think my goal, my plan is I'm just going to do a form of drag soldering and then come back in with solder wick. Or maybe not. I know what I'm going to do. I'm going to get I want to look at with a microscope. So unfortunately, I have ruined the USB port on my microscope, so I can't just plug it into the computer and show it as a camera, which is something I used to love to do. But we'll try, and I want to take a look at this port on a microscope. So let me take a look first. Yep, I am, oh, maybe not that port. I wonder, is that connected to anything? Yeah, okay, so that pin didn't do so well. Which I can see it now. All right, so let's take a look at this one. And I know, I'm sorry, you can't see what I'm doing, but I'll try to show you in just a second. Yeah, that pin as well, that makes sense. Because they're on the plane or on the copper pores. All right, let's look at this one more time. It's kind of gross, but it'll work. So let me see if I can show you what I'm looking at. Let's see, is this gonna work? This doesn't work for me to show you in real time because this is totally janky, but you know. There we go. Come on. All right, so yeah, I was just looking at the port and trying to see. Actually, I look at this, I don't like it. Yeah, I keep messing that up. So what we're gonna do is hit it with some flux. And then, oh, nope, not that one. Try this one more time. It's so much better. And then this guy over here. I've got to get this fixed. All right. Yeah, actually this microscope broke while I was finishing the Apple II video, and I bought USB ports to fix it, but I haven't gotten around to installing any of them. I'm a little bit nervous about what's going on back here. I need to look at this. I can't. I need. And bring this in much closer. Okay. Okay, I feel a little bit better now. All right. How in the world can I test this one? Because I feel like anything I plug into it might blow up. Oh, I know. Okay, let's clean it up and then I've got a way to test it. Hey, 48K. Good to see you. Well, the sponsor I had 5 years ago was because it was through the Element 14 community. And so they're owned by Electronic Distributor. And in fact, the whole reason we created Workbench Wednesdays was because they approached the producers and were like, we want videos to demonstrate our soldering equipment. And they're like, yeah, our project videos don't really do that. What if we made a show that just does review stuff? And I was like, well, what if I did a show that teaches things instead of just reviews? And they're like, whatever, just send us a video. So that mostly came about because of them. Which, in fairness, I should point out, in full disclosure, the soldering equipment I'm using right now was given to me back 5 years ago. So, by the way, so I'll put up a link later, or you can go look for Workbench Wednesdays on YouTube now. The 86th released episode of Workbench Wednesdays went live yesterday. It was on the Picoscope 7 software. But it is the 100th video where I appear on the Element 14 channel. So it's actually the only other person, so obviously Ben Heck and Felix, especially Ben, I think Felix shows up in obviously more videos, and then Karen also shows up in more videos. However, when she started doing the learning circuit, she stopped around number 88. So I am technically, standalone videos, I have the second most content on the channel, which I think, or I appear in the second most videos. Again, super qualified. It's not even worth saying that because it's super qualified, but I was just like kind of surprised by it. What's really surprising to me is I remember doing videos about 60 videos ago as if they were last month. Like there's stuff where I go to look it up myself and I'm like, wait, that was number 30. And it seems like I just did it recently. So, which is funny because my short URLs are all the episode numbers, but I don't remember any of them. So, thanks, Geek. Mega 2 was just last week? Yeah, it was. Yeah. Yeah, and that was a project that took only about a month, so. All right, let's grab this, and then we'll throw this one on here, and then I think I gotta get some more. Real quick, hey Grativer, nice to see you on, nice to see your name pop up. I occasionally see you on the social medias, liking and actually replying to stuff too. Not always my stuff either. I just see your name pop up. Such a unique name. But Geek, if you remind me, if you don't find it, they're in the gearbox. You can turn mod buttons on all the time, which is probably what you didn't have if that's not how you fixed it. All right. So, hey Ramones. Did Arcus stop streaming, or are you watching two streams at once? All right. So what I was going to show you guys so that I get a camera shot of it. So these are the Panoma connectors that I'm using, 72918. I couldn't find anything else that works as well as this. If anyone can find like a cheaper option, like this bag is about $1 per pair, or $1 each, maybe $1 per pair, I think, which isn't a terrible price, but I had hoped to find something a little more cost effective, and I wanted something that had a smaller stud on the back. But overall, when I found the multi-pack of these, I was pretty happy. A Dremel can fix that issue? Yeah, good point. I just don't like Dremel screws. I mean, what I would have liked to have found is one that was just shorter. But I'm glad that they at least sell them in a quantity package, because they are pretty expensive one by one. All right, so here's what I was thinking we can do. Where did I put the breakout board? I had a USB-C breakout board that I used for another project, which I was thinking about soldering tonight if I have time. Did I put it back in here, which is where it should be? Okay, I can use that one. It just won't be as... Okay, I think I'll just use this one. This isn't actually what I was looking for, but it'll work. So I have these USB-C breakout boards. And then all we need is a USB-C cable. So I can plug it into here. And then I can plug it into... Oh, that's not USB-C. It tricked me. That's micro. Shoot. Shoot, 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 shoot. Shoot. Shoot, I said. I didn't say another word. This one looks like USB-C, but it... Well... I don't like that one, but I think it'll work. Darn it, I wonder what I did with my other one. Because I had one... Okay, I'm not going to worry about it, because this is going to work just fine. I wonder if I put it in the power profiler box. That might actually be what I did with it. Yeah, pass through. Yeah, that's why they're that long. Yeah, because they go through. So they usually pass through insulators and panels. Yeah. Yeah, I know that's why it is the way it is, but it still don't like the way that it is. All right, so there, we'll plug that into there, this into here, and then if I can believe this, what's the USB power meter that you have? Is it like a, is it something that plugs inline, or does it do something more? Okay. Sweet. That works as expected. I'm really excited about having a USB-C adapter for my power supply. That's probably the one I'm most happy about, even if I made it wrong. Did we clean the flux off of that? Yeah. Okay. All right. Now, I don't care about those resistors. The question is, do we go ahead and do the screw terminal one, or do I just wait? Yeah, you know, I do want to do this. You know what I'm going to do? I know what I'm going to do. Even though we messed this one up, I'm just going to just leave it, because it doesn't matter. It's still usable, even the way that it is. So why don't we just finish this one up, and at least I have one of the... I just won't have an LED on one side. It's not the end of the world. Yeah, that's what I thought. Okay. But then this way, I have, because I've wanted this screw terminal one for a while because my main power supply doesn't have the screw type banana connectors. And so like if I want to put just wire into my power supply, I don't have a way to do it. And so with this one, I'll at least be able to put wires directly in. All right, and then on this one, let's make sure. So like, I'm pretty sure I'm going to be done with these irons for the moment, so I'm going to just cover them in solder. And then that way, they're less likely to oxidize. Although this one, I really jacked it up, but that's okay. I'd rather have it done than not done. Print a spacer. Yeah. Actually, I did think about printing like a little cap or something to go on top of to go on top of these sections, just also as a way to like do red and black. But I haven't really given that much more thought than a passing consideration. Yeah, what did we mess up? Yeah, I figured somebody was going to call me out on that. Oh, that's too funny. When I said we messed it up, I was like, someone's going to be like, what do you mean we? Any info on how to config 2-button Chinese soldering iron? I don't know. I don't know. I mean, it depends on whatever firmware it's running. So, and I don't know the various firmwares well enough. That might be a good question for Ask Electronics on Reddit or the EEV blog forums. But I would definitely post pictures of the iron and a link for which one you bought, because somebody might recognize it. You configure. So over on Twitch, 48K said he configured his 2-button Chinese soldering iron by returning it to Amazon. Man, I gotta rant real quick. So I bought some chairs that I didn't end up using, like outdoor lawn chairs, and I was like, okay, I'm just gonna return them because they're brand new, they're relatively cheap, and I'm like, I'll just return them and buy them again if I ever need them. So I set up the return, and they came in, it was 2 orders for a 2-pack. And the first order, or so I set up the first return, and it's like, okay, we'll give you a return code for these. Do you want to return anything else with this item? So then I did the other order that had the other 2 chairs, and it's like, great, here's your QR code. And it gave me the same QR code for both items. So I put all of them in the same box and returned it, and then Amazon said you didn't return one of the orders. And I'm like, and then trying to chat with them, they could not understand what I was talking about. It was like so frustrating to get them to realize I had already returned the thing they're asking me to return because I followed their return process. Okay, I said return enough times. Yeah, pine sills are the, those are kind of the, pine sill, did I spell that right? Maybe it's pine sill, are kind of the gold standard of those things. I have a TS80, and then there's also the TS100. Now you have to be careful because not all those models have the same microcontroller, and a lot of the copycats all use the same names, even though they're slightly different. But there is a open source firmware called Iron OS. And so like on my TS80, I replaced it with Iron OS, and it adds a bunch of features that I wished the original had. And I really like it. Like, I don't think I would recommend. I'm struggling. I'm close to recommending those kinds of irons as a full-time iron if you don't solder every day. Like, I just got it so that I could travel with it when I go to conventions, which actually cracks me up. Okay. Anyway, so that's one of the things I would say is whatever you have, see if you can get a replacement firmware, like an open source firmware, because it'll probably work quite a bit better than whatever it came with. Okay, so I've had this thing for like 3 years. I've been to, I'm just going to say 5 conferences minimum with it. The only time I've used that iron was we did that Jim Herney binary solder kit, which was great. Like, it was like a 2-hour soldering session, and my USB-C battery powered it just fine. Like, I could have gone at least for another 2 more hours. So I've been to 5 conferences with my iron, and I think it's been used at every conference I've taken it to, except by me. I've never used it outside of my house. So I went to Teardown in June, which, by the way, if you're in the Discord, I posted a link to the capacitor talk that I did. It just went live yesterday. At Teardown, I went to a workshop, and we had to solder stuff to a Pi Pico. And when you do the math real quick, we realized that, in this case, it was actually we as a group realized we could only have like 2 or 3 irons on each table. And so that meant like 8 people were sharing 2 irons. And I was like, why didn't I bring my soldering iron with me? For some reason, I forgot it. And I'm like, I could have actually finally used my soldering iron at a conference. Anyway. Hey, Squire, good to see you. Okay. So, that is all. Oh, that's got, man. I still have a ton of, too much flux residue. I need to get a small wrench, but I'll do that later. Okay, so check this out. I'm super excited. Before the stream started, I had this adapter, which was USB-A, and I've used it tons. And now I have one for JST PH, I think that is. Whatever the Adafruit LiPo batteries use, a 2.1 millimeter barrel jack, USB-C, even though I did the port wrong, and a screw terminal. And there was much rejoicing. Yay. Wait, I think I actually still have that on here. Where's it at? Does this work? That works. I guess I don't have it. Oh, there it is.
There was much rejoicing. Yay!
All right, I'm pretty excited about that. Left-hand mode in Iron OS is great for dual wielding. Oh, that sounds really cool. I want to do that now. Okay, so where are we at? It's 8 o'clock. I kind of want to try one of these out. Specifically, I want to try out the LiPo battery one. Oh, no, I don't, because I don't know how to use that thing yet. How can I do this? Okay, we're just gonna try something. If I turn my camera like this, Oh, that's as far as it's going to go. Okay. That's not going to work. And now it's not straight. Okay. I really want to try it out, but my little power supply is not working. And so I don't trust using it anymore. Okay. I think I'm just gonna have to wait because I don't have a good setup. The irritating thing is Element 14 sent me a new power supply. This would be great to play around with them. But, Okay, I want to do one more thing before calling it a night, and that is I need to solder a completely different board. So I'm going to go grab that real quick, and we're going to work on that. It's not... Where did I put those, actually? Where did I put the... Yeah, it's right here. Okay. All right. So this is for a project that I've been working on, which is outside, so I can't show you. But this is for those that were here during the lockdown times, one of the earlier projects we designed was called the SHLT wing, which stood for Sound, Humidity, Light, and Temperature. And I had several, though we made a couple. I did 2 revisions of the board because I screwed up the first one. And then I am currently recording a video for a sponsored video from Macrofab because they produced these for me. And so this is version 3 of the Shield. It still has a microphone. No, that's the temperature and humidity sensor. Hell, I don't remember. Anyway, there's the 3 sensors, the RTC, a micro SD card, and then on the back, I'm going to put the connectors for battery. So yeah, so I want to solder up one of these. Yep, actually 48K. That was the joke that chat came up with. SHLT, so that it sort of looked like that. Now, Macrofab kindly asked me to change the name for reasons I can't even comprehend. And so I did. And so, okay. So first thing we got to do is I need to grab my X-Acto knife and cut 2 of these. Actually, I'm only going to cut this one. We're going to do this one. Because the way that I designed this is for the RTC, you can either use a coin cell battery or you can just use the LiPo that's connected. And so I want to, by default, it uses the LiPo battery because I thought that'd be the easiest. And so I need to figure out which pad we need to cut. Okay, it is that one. So I'm going to come in here with Mr. X-Acto knife and ever so gently gouge the crap out of it. Ooh. Well, I definitely broke something. Okay, so now we can test this and see. Well, that didn't work. Man, I could have swore I did this. Yeah, I'm okay with that idea too. No, I went with, I'm calling it the Bald Sense wing. The reality is, it's not, originally I designed it, my original thought was I wanted to make a wing for feather boards that could plug on, and it has those 4 major sensors plus the RTC and the micro SD card. But the sensors I'm using are really ridiculous. And so it's really not a very cost-effective tool, but I don't really care because it does enable me to do a whole bunch of things that I couldn't really do before. But it does at least address the, like, I didn't want to design the microcontroller side at all. And so depending on what feathers I have available, like the microcontroller side, this board is very flexible for me. Because even though I have like the M0 logger, which has a micro SD card socket on it, I also have one that has a LoRa radio, which does not. And I have like the Feather S3 that Unexpected Maker sent me. It has a light sensor, but none of the others, right? And so anyway, from a design perspective, it does what I want it to do, but it is kind of ridiculous in terms of its design, in terms of the BOM cost. That was, because like the main problem is the light sensor is no longer in production. So you have to pay a lot of money to get them. They're readily available, like everyone's got like thousands of them, but they're all on lifetime buy now. All right, so I cut that, and now we will try and bridge the battery side, which worked really well. I tell you what, I can't believe it took me this many years to figure out how to do solder jumpers correctly. The number one trick to getting those to work well is to just drop your soldering iron down to, like, in this case, I drop it to 250 degrees. You drop the temperature, and those solder jumpers are super easy to hit. Now I feel like there's one more. Oh, there's one for the LED. Yeah, let's go ahead and do that one, because they're so easy to undo. I'd rather have them on for now. So we'll do the LED. What did I just say about being so easy? Yeah. So the LED is, did I just mess it up? I think I did. Yeah, that's not so good. It was fine until I whipped the board across the table. Yeah. All right, then let's get this one. Okay. So I did the power LED is on, has a solder jumper so that you can quickly disable it. Whoa. Whoa, there's all kinds of solder left over on that. All right. Well, that's not working out the way I thought it would. There we go. There we go. There we go. Okay, that's much better. That's looking good. I'm happy with that. Very so gently. Since when does BE Labs design things down to a cost? Yeah. Actually, in the video, I'm going to make a joke about how I don't know why people say designing is so difficult when you spare no expense. It's actually super easy. But since it's only a couple of us, the reality is what I'm doing is I'm actually making an entire series on taking an idea and for an IoT device and going through the stages of doing everything wrong to get to a viable product. Because like for now, it's like, okay, from a prototype point or proof of concept, this works fine. And in fact, the reason I picked all of these sensors is because there were Adafruit libraries for them. And so even though I have no intention of using Arduino code or MicroPython, CircuitPython in the final design, I want to plug this in and put it outside and see if it works, everything works really well. And so what's going to be a lesson later on is, okay, I designed with these really ridiculously expensive components. What can I do to reduce the cost? Well, obviously get more realistic components, right? And so that's something that I can address and talk about. But early on, I mean, as a proof of concept, this is still a viable path, right? I traded off the time it would take me to develop code to talk to the sensors for just buying more expensive sensors. Even having somebody else build them, it still ultimately saves me money because like I spent zero time debugging these boards. They work off the bat, and I absolutely love that, actually. Okay. Anyway, Internet of Expensive Things, IOET. I like that. But also, I mean, from a product perspective, this isn't, to me, I mean, it still needs, I mean, I've got to get the parts cost down, because it is like that light sensor is just killing it, because you can actually get reasonably priced. The rest of the parts, even though in small quantity are expensive, they're reasonably priced at 1,000 or 10,000. However, the light sensor, the problem with the light sensor is that it's not available anymore. And so I've got to deal with that. All right, so I think they used lead-free solder. So we're going to add a little bit of lead to make things easier. So one thing when you're using like coin cell batteries, like this pad layout, kind of, you do need a little bit of solder on the pad, on the center pad, so that it actually connects with the battery. You don't want too much so that you actually damage the battery, but you need some so that there's some planar contact. And so that's what I'm trying to do here, is just get a little bit of a slight, what do you call that thing? The bubble? I want to say the hibiscus. It's not a hibiscus. What is it? Meniscus. Yeah. Ow. Ow. Yeah, but what I don't want either is a sharp point. This will probably help. It'd probably be better if I was using hot air. Oh well. I don't have a sharp point. That's all I care about at the moment. Okay, I need to go get a battery holder. I didn't plan for that. Hey, 48K. Yeah, well, sorry. Actually, I haven't. Yeah, never mind. Slap an LDR and use an ADC. Yeah, that's what I should have done. Because actually, the light sensor I'm using is not that great of a light sensor. It's actually more of a color sensor, and so when it's outside, even in the shade, there's too much sunlight, or the sun is, even in the shade, it maxes out the light sensor. This batteries or battery accessories? I need the battery holders. Where did I put those? Come on. Okay. Grab this, and then I also need to grab some headers, but I'll just take the whole box because I don't want to look through them at the moment. Oh, okie dokie. One bit. Well, the way that I had justified it to myself back when I think I was selecting it was the idea of having a color sensor was a lot more. It was like, oh, well, you know, if I'm trying to like put together a whole bunch of sensors, maybe it makes more sense to do this. And it's like, and now that I have that ability, I'm just like, I'm not sure how I feel about that. Just a second. Oh. Pretty sure I know what this is going to be. Okay. A call at 7:30 from Alaska to talk about my health insurance. Yeah, I don't think that's real. All right. Oh, wait. Before I put this on, I did make a big mistake on these boards. I need to add some Kapton tape. So the micro SD card socket is really frustrating. And if you guys remember the first version I did on this, I actually put the pins on this side, but the pins are the same side that the card plugs into. And so to put it up on the edge of a board like this, where do you put the decoupling capacitor? Well, I put it back here, thinking I could install the battery and then put in the cap. However, I did not have a model of my battery holder, and my battery holder basically would touch the cap. So my SD cards have no decoupling capacitor. MacGyver, good to see you, by the way. Facing the challenge of creating my first electronics product, with 0.5 millimeter pitch. So there was a really great talk at Teardown 2023 done by Ptor of 1-Bit Squared and his Joe Fitzgerald. I just remember him, Joe Fitz. And the talk was, I forgot what the cute title they called it, but it was basically, don't buy a pick and place machine, and if you decide to, here's why you shouldn't. And basically, they came back with, unless you're spending on the order of $100,000 for the machine, there is a very high cost in terms of time to operate it. And so I mean, it's, you really have to, like, don't think you can spend even $10,000 and have something that saves you significant amount of time. It turns out there's just a lot more to them. So anyway, if you go to Crowd Supply's YouTube channel, you should be able to find the Teardown talk from last year. It was at 2023, and it was something about pick and place machines. You could also go to that channel and find a video posted yesterday called "Stop Using the Wrong Capacitors," which was my talk from this year. And yeah, see how I didn't actually only bring up the pick and place one to plug my thing. It is actually a really good talk, and it actually convinced me not to get a pick and place. And now that I'm starting to use, now that I've got to experience the joy of having a contract manufacturer assemble boards for me, I really don't want a pick and place machine. All right, let's just get. I am not getting this anywhere near level or straight. Okay. I'm still not happy with that. Yeah. What would probably work better is if I just did this. Yeah. Because I want this to be more flush than straight. And we'll do the other side. And then after we put the headers on, I'll install the battery. Okay. So I think that's all I had to do. The power LED, fix the clock, and then the silly. You guys are talking too fast. Yeah, PPK is awesome. Bad caps, what you gonna do? Oh, that's what I should have done. No, I turned the iron back up, but good thing you asked. Okay. So now I need a breadboard, which, no way. I don't have one next to me? That's weird. Let me go grab a breadboard. Is there one in here? No. So that we can do the headers, and then these will be ready for me to do stuff with them. This will work absolutely fine. Okay, so we need headers. Yeah, I mean, frankly, and that's where I'm seriously saying, like, I do mean this. If you're in the 10 to 100K range for a pick and place, then I think there probably is something that's really worth considering. I didn't mean to make any assumptions when you said you were looking at one, but I think too many people are looking at the $1,000, $2,000 machines and not realizing you still need to spend another $2,000, maybe $3,000 on feeders and accessories, power sometimes. And so it's like, okay. And then the biggest challenge is a lot of the pick and place machines all have proprietary software. So they're really difficult to work with. Well, it's proprietary software and it's not very good. So I guess, I always forget about Stephen, what's his last name? It's H. I forgot the name of his open source pick and place. That might actually be worth looking at. I think in terms of it's relatively inexpensive, but it's also got a lot of really smart people that are trying to make it a viable product. All right, so now okay, and then I'm going to use these as a template so I can cut the other ones faster. So I'm just breaking off headers. I'm comfortable putting headers on all of these because they're all going to plug into a microcontroller board anyway. One of them I should probably put in upside down, but I've got several more boards that I can do that with, so I'm not going to worry about it. All right, so that size is correct. This size is correct. So now I need 3 of each. Let's do this. Break. Let's do this. And break. All right, 1, 2, 3. Oh wait, this one. Okay, how's this look? Magically, that is the correct size. That's crazy. Okay, break this one. All right, so I've got 1, 2, 3. All right, so we're going to take these and this, and then we're just going to turn it upside down, plug it into the breadboard. Ew, I don't like how hard that's going in. That's not a good sign. I think I got in the wrong holes. No. What's going on? Yeah, that's what I did. I was off. Okay. Oh, why did it go to sleep? Hey, if you're still here, have a good night, 48K. Thanks for stopping by. Good to see you. Hope you are able to start streaming again yourself. And if not, that's cool. I get it. Life is funny sometimes. All right. Oh, you're not hot. That's why. Okay. All right. Press down. Give that a second to cool. Press this down. Give that a second to cool. Press this one down. Give it a second to cool. Press that down. Give it a second to cool. Yeah, attack. That's actually one of the things they brought up in the talk I was mentioning, is that on those really, really inexpensive machines, the software is just absolutely terrible. And it's like, wait, it's like, well, yeah, but then the cost to develop new software, you know, especially if you're in a production environment where it's like you're willing to spend money on it, it's like, oh, but it would have been cheaper just to buy a better machine with better software. It's all, and the problem is it's all proprietary, so it's like, which in itself isn't necessarily a bad thing. It's just that it's like a lot of niche technical tools. The people that wrote the software aren't really, they're not thinking about user experience and user interface. They're trying to write software to make the thing do the thing it's supposed to do, and that's it. You know, like, we used to see the same thing with digital oscilloscopes 25, 30 years ago. They were basically, it was basically one of the firmware engineers wrote some code to wrap around the memory controller and drew the waveforms, right? There wasn't a lot of thought in terms of how things should be laid out and where they should go. Or if they were, it was all around the, well, this is how it works, not how would somebody use it kind of thing, mentality. I don't really like those solder joints, but that's what we got. Okay. Is OpenPMP a Java application? Is that what I just saw you say? All right. This is looking like it's going to be a little bit better. You know what? This breadboard's not very good. I can see it's not planar, and I'm not sure why. I'm going to try getting this one, even though it has a label on it, but I want something that has a stiff back plate. Oh God, that didn't sound good. That sounded really bad. Like, that sounded painful. Okay, why is my little trick to make things easier stressing me out? Like, wait a minute. Wait a minute. Okay, yeah, that looks a lot better. So just like before, what we'll do is put this on. I'm going to put some pressure on the board just to make sure it's more or less flat against the thing. What was going on with the other breadboard is I noticed that the headers were not going in planar. I don't know if that's the right word, but I could see like a mound in them. Oh. And so it was bothering me that I think I was putting more stress on the PCB than I should have. Oh, I forgot to add tape to this one, but that doesn't matter unless the battery gets installed. Yeah, so I guess these I could put the decoupling cap on the for the thing. So maybe we'll do that. No, I want to do it with hot air. I'll do it later. So my hope is that I have some feather boards with either an ESP32 or an ESP32 or an ESP32, because that's all the code I've written so far. Which really in CircuitPython doesn't really matter because it's all abstracted anyway. It's just that I know that the Wi-Fi stack works with what I've written. Like there's Adafruit has some other boards that have is it an AT-Win? I forgot what the name of the chip is, but it's a different Wi-Fi chip. And I'm just not sure how well supported it is. Never tried this because you're worried about melting the board. Yeah, you do have to be careful. So what you'll notice I'm doing is I alternate pins. So I'm trying to prevent like a large amount of heat developing in one part, like in one area of the board. So I usually try to do like alternate pins, and then alternate. You can even go so far as to go back and forth, but I just feel like that takes too much time. But if you're relatively, I would actually say, now they say that, if you're relatively inexperienced with soldering, you may want to do it that way. Is go back and forth, just because you're going to get less stress. But yeah, as long as you keep moving, the board will be fine. You won't damage the bread or the breadboard. I used to have a breadboard that was like all yellow and nasty and gross, and that's what I would use, but I don't know where it's at. Because even though I think it's perfectly safe to do this, you know, sometimes sometimes it's not. What is going on? Oh, wait. Yeah, I did get it off by one. I think the actual problem I'm having is the post on these. I don't know what the post on these is really short, and so there's almost nothing sticking through the back of the board. So that when I go to put it into the breadboard, it's not. Anyway, I'm just trying to make excuses for why I'm having trouble to do something that should be really simple. Okay. So I do the corners just like, you know, when you do cross bolting of a, or when you what it's called, the cross pattern, when you do bolts here, you know, whatever. That's all I'm doing here, is just so that I try to make sure that the board is getting flat against the header pins. It's probably overkill, but And let's get this one. This one. This one. This one. This one. This one. And this one. Awesome. Okay. Oh, okay. We got a boatload of stuff soldered tonight. I'm very happy. So these sensors, I'm going to, I've got to go find microcontrollers to plug them into, but that's a whole nother subject. So yeah, so the sensor boards, these are, what is going on with this one? Crap. Oh no. Let me know when you see the mistake. Dummy. What's the best way to get started with soldering? Turn on your iron. I find in every session so far, that's the best way to start. So if what I generally would recommend is some kind of soldering kit. So if there's an actual thing you're trying to accomplish, then maybe go get like an Adafruit or SparkFun kit that you can solder together. Or more likely, eBay, AliExpress, Amazon. There's tons of like LED soldering kits you can get that are like a PCB, a handful of LEDs, and usually like a 555 timer and a handful of passive components. They're relatively easy to just kind of just throw them together and no big deal. So that's probably the easiest way to get started. Well, the good news is I just won't have access to the battery, and that's all that matters. Well, oh wait, no, I need that. Shoot. Okay. Well, I'm gonna have to get the solder sucker out for that, and I don't want to do that right now. Off by one is a software thing. Yeah. If you, oh hey GB, I missed you earlier. If somebody said something to me or asked a question and I missed it, I just missed it. It wasn't on purpose. Just FYI. I haven't gotten back into the reading chat kind of thing. Yeah, actually, I really feel like whenever somebody asks me about getting started with soldering, some kind of kit is the best thing. And then maybe after you do one or two kits, at some point you should learn how to do removing parts and stuff. And that's where you can go buy something from like the 90s or early 2000s, like a VCR, and learn how to desolder components from it. Because most of it's going to be through hole. There's going to be lots of through hole, maybe some surface mount that's still relatively big pitch, and you might be able to recover some interesting parts from it. So, okay, so we got 3 bulb sense wings sort of ready. I have to fix that one because it's actually missing the battery pin, which we'll need for the RTC, right? Yeah. Well, and you need the... Technically, I could actually wire, or excuse me, sorry, I sneezed and almost burped. I burped and sneezed at the same time. Actually, on this one, I could put the coin cell battery, and then the only thing that won't work on here is the battery voltage measurement. So maybe that's what I'll do instead of trying to, yeah, maybe that's what I'll do. I gotta figure out where I'm going to put this to do its sensing. So I did want to do one more thing. I wanted to throw this battery in. Fight to put a pin in there. I don't know. I might actually just do that. Like, if I could find the pin I just pulled out, I could put this in there. Oh, I know what I could do. I know what I can do. I can use these test headers that I have. So I bought some of these a while ago where the post and the tail, I think it's the post and tail, I forgot the two names of the parts on a header or on a thing like this. But I got these where they're actually slightly different, but they're basically the same size. And these are great because if you put them into like a board like this, there's still enough pin left over that you can either plug it into a socket. You can plug it into a socket, and then you have somewhere to clip a test lead onto. But yeah, I could take one of these posts out and just shove it into this hole and then just cut off whatever I don't need. So maybe that's what I'll do. It'd be fun for you. Yeah, I'm not going to do that now. I think I've made enough mistakes at this point that it's time to say, put the things that cause fire away. In fact, shut that off. Okay, so yeah, I'm pretty excited. We got those going. These are my power supply adapters. So this is a video I'm working on like literally right now. This is going to be, I haven't actually figured out what, oh, that's what I was doing. I was putting this on. So yeah, so this will be coming out hopefully in the next week or so. So we'll have something on that, and then this is going to be after I do the Cerberus video. Then I'm going to do something on these adapters, which I'm really liking, and then I'll actually, this will show up in a Element 14 video because I actually needed this for that video. So we'll see how that works out. Yeah, that'll be fun. Yep. Yeah. No, LT. That's actually, I wish I remember that, because people always ask me things that I learned from doing that project. And that is legitimately something I learned in that project, is when you hit a point where you're just making mistakes or things aren't going well, it's better to stop. Even if it's like, oh, I just could do this one more simple thing, because one more simple thing can turn into a serious issue. And yeah, I agree. That's one of those discipline things that over time you're just like, oh, I guess I am human after all, which is a really crappy thing to admit, but all right. So I do have a couple of things to share. Well, I only have one link. So there was a new Workbench Wednesdays that came out yesterday. I think it's this. So it's on Picoscope, the Picoscope 7 software, which actually came out a while ago, but when it first came out, frankly, it was very unstable. So I gave it another look, and now it's really good. So there's that side of it, but it's also the 100th video that I appear in on the Element 14 channel. So I was actually leaving it as somebody, I was trying to leave it for somebody to figure out, but the editor was really excited, and he added a animation of thumbnails. It's 100 thumbnails. So I think, because what happens is in the video multiple times I bring up the number 100, and I was just going to leave it at that and see if people were like, why did you keep saying 100? What do you know, what's wrong with you? So we're not human, we're just slow. We're just slow and accurate pick and place machines. I am definitely a pick and place machine that is prone to errors, that's for sure. I'm probably made with some really crappy Chinese software. All right. So, or the crappy software that comes with Chinese machines is probably a more appropriate way to say what I was just trying to say. Okay, so probably stream next week. Don't know what we'll be doing, but probably do something. We'll have a different setup because this is probably the last stream I'll do with this setup, and maybe I'll be able to go back to having more than one camera, because if I had my other camera, then I could have done the this is the board I was looking for earlier. Anyway, so go check out that Workbench Wednesdays video. There's also, I'll start promoting it probably tomorrow. There's my talk from Teardown. The easiest way to find it right now is either go to Crowd Supply's YouTube channel or just go to my Discord. And I posted a link in the other stuff channel. But that was a 25-minute talk I did on how to choose capacitors. And basically I try to talk about in terms of if you're going to use a ceramic, think about a couple of things. Same with aluminum electrolytic and then supercapacitors. So I had a lot of fun with that one. A lot of information in 20 minutes. So, all right, guys, thanks for hanging out. As always, remember, please find time to do something you enjoy. And if you do, please share it with other people if you want.